All right, let's get started on the trig. Like I said, I'm not going to be here on Wednesday or Thursday of next week. So I want us to try and get a little tiny bit ahead. It looks like it might be Mr. Azaday, which would be good news, but I can't guarantee it. And so we'll do what we can. Angles in standard position in quadrant 1.
Oh, I totally remember this.
Good.
It's coming back.
Whoops. Okay, remember this coordinate plane, right? Basic fundamentals of graphing here like this. It's obviously broken into 4 sections. Given that they're fourths, we call them quadrants. We number them: quadrant 1, quadrant 2, quadrant 3, and quadrant 4, like so. What's that? Hey, it's also very important that we remember our SOHCAHTOA.
Could so live without this.
All right, you don't need to write this down. In fact, please don't, because I'm going to go through it fairly quickly. But what is it building on? This unit is remembering the Pythagorean theorem, right? That's a squared plus b squared equals c squared. The primary trig ratios, which is SOHCAHTOA, and using those trig ratios to solve problems. All right, you can read that. It's all in your book. You can read that later. This is very important, though. Copy this down. This is a general form for describing points and angles. This is what we're going to draw this picture like 100 times. Lowercase letter theta, Greek letter. It's just one we typically use for an angle. Not always, but often. Okay, so this diagram, we said we're going to use it over and over and over again. So let's get real comfortable with it right now. You remember, I'm hoping, that when we write a coordinate pair, or a point, it's given a letter, usually, to identify it. P is very common, because it's P for point, but it doesn't have to be. You can call it whatever you like. And we always write the x coordinate first, followed by the y coordinate. It's absolutely imperative we do this right. So, given that that is our point P at x comma y, I'm going to drop a line down, and I'll do it in a color here. Let's do it in orange, because today is like an orangey kind of day. And that line is now 90 degrees. I dropped a perpendicular straight down. How long is that line? about that big. It's y. All right, because that is the point y right there. And so that line is y long. Make sense? What about, let's do blue. This line here. Well, this right there is point x. So how long is that line? Well, it's going to be x units long. Sensible? So, what's an expression for r in terms of x and y? How would I write r using the x and y's?
Be like x squared plus y squared equals r squared.
Perfect. Only I don't want r squared, I want r. So what do? How do I get rid of that squared?
Square root of.
I can square root both sides. So I'm going to square root those now, and we're going to get r is equal to the square root of x squared plus y squared. Straightforward? Cool, nothing funky. All right, we all know how to do that. Wipe that out. Shouldn't have put it in the middle. Write a value for theta. That is theta. Theta is like a circle with a line through it. It's just a symbol. It's the lower Greek letter theta. It's just a symbol for an angle. That's all. We'll use other symbols as well, but that one's pretty common. So how am I going to write that angle? Well, I'm going to have to. Remember this? Let's pick one of them. Let's do the first one, just for fun. You remember what it stands for? SOH? Sin of the angle is equal to the opposite over the hypotenuse. All right, the sine, it's not sin, it's sine.
You're pretty.
So the sine of the angle is equal to, well, what do we have as the opposite? Y over, and what's our hypotenuse? R. Only that told us what the sine of the angle is. How do I find the angle? Angle is equal to, we take the inverse sine of y over r. Do you remember doing this trig stuff? Yeah? We could also have used cos, and we could also have used tan. It all would have given us exactly the same answer. Well, to do the last one, we have to make an assumption. And the assumption that I'm going to make is r equals 1. When r equals 1, we have a unit circle. And we'll get into the unit circle a little later on. We're just going to leave it for now. But what it essentially means, the unit circle is I have a circle drawn around the coordinate pair where the radius of the circle is 1. That's all it means. We're just declaring the radius is 1, which means it's going to cross the x-axis there at 1. It's going to cross the y-axis here at 1. It's going to cross the x-axis here at -1 and -1. Easy enough? And so if my r is 1, what's the x in terms of r and theta? Well, we just had, right? Sine. Oh, let's do cos for this one. Cos theta equals, no, adjacent over the hypotenuse. So cos of theta is equal to, what's my adjacent? X over r, only what's my r? And so what can I say my x is if we're talking about a unit circle? X is equal to cos theta. You follow how I did that?
Because you have to times each side by 1 to get rid of 1.
Well, it's something over 1 is just itself, right? So let's do this now, and let's go for y. Sine theta this time is equal to the opposite over the hypotenuse. Sine theta is equal to y over. So we could say y is equal to sine theta. So in other words, my P could also be written as cos theta sine theta. That's assuming that my r is 1. What if my r wasn't 1? What if it was 2? This would become a 2. How do I get rid of the 2? I would times both sides by 2, in which case it would be 2 sine theta, if my r was 2. Fair enough? Okay. So, there it is. Pythagoras, we all know what it is, right? It's just to kind of refresh a little bit. A squared plus b squared equals c squared. Right? So c would equal the square root of a squared plus b squared. I'm pretty sure you don't need to write this one down. Right, there's your SOHCAHTOA. It's amazing to me. If it says sine B, for example here, the side that is a part of the angle is the adjacent side. The side that's making up the angle on the other side is the opposite. And the longest one, the one that's opposite the 90 degrees, is always the hypotenuse. What if I didn't want angle B, though? What if I wanted angle D. What if that was my angle that I was looking at? That's now the adjacent. That's now the opposite, but that one remains the hypotenuse no matter what, because it's opposite to 90. All right, so we have to make sure we get our A correct and our O correct. The way I tend to think about it is A, it looks like the angle symbol, so it's the one that makes up the angle. All right, otherwise, it's just adjacent, which means next door. It's not hard, but there will be many of you who will mess them up, so try not to mess them up. Remember which they are. All right, here we go. You've got this down. Don't write it all. Don't write all the words. I would make sure you've got that picture nice and clean, though. It's the same thing that we just did. All right? R, remember if R was 2, it would be 2 cos theta. If R was 4, it would have been 4 cos theta. So R cos theta, comma, R sine theta. Which part do you not get?
It'll click.
Do you understand where the sin and the cos are coming from in there?
Kind of.
Right, so like that, right? That's my R. How long is that? That's Y. Right? That would be my Y point, right? X comma Y. So that's Y tall. Yes? This is going to be my X point, which means that side is X long. So if there's my angle, right? X is the, compared to that angle,
Adjacent.
right? So we would say cos theta is equal to the adjacent over R, over the hypotenuse, right? So cos theta is equal to X over R. Multiply both sides by R to get rid of it.
Oh,
X
I
equal
get it.
to?
Makes sense. Where it was coming from now. So I was just like,
We turned it into 1 before, because then we just make it go away really easy, right? Okay, happy enough with that diagram? You're going to use it, like I said, you're going to over and over. So the point P, 4, 7, is on the terminal arm. Okay, terminal arm is just the name we give to the line that we're about to draw. So 4, 7 will be somewhere up around about there. That's point P at 4, 7. We start from the origin. We draw our line through that point. That is our angle theta. So, how high up is that right there, that point? That is 7. This point here is 4. Which means that length right there is 4. That length right there is 7. So what I've essentially got is a right triangle, 4, 7, that's my 90 degrees, that's my R. squared is equal to a squared plus b squared. R squared is equal to, it's not R, it should be H, yeah, is equal to 4 squared plus 7 squared. R squared is equal to 16 plus 49. R squared is equal to 65. R is equal to square root of 65. Now, do I have to do the plus minus thing here? No, because we can't have a negative, so it's not going to count. Can I leave it at 65? Is there any way to simplify this? Yeah, so we're either going to have to turn it into a decimal or simplify. There is no root simplifying for 65, not that I can think of offhand. It's not going to work. So we could go to a decimal. I'm going to suggest, unless it tells you, give your answer to the nearest centimeter, keep it perfect. Keep it as the root. If it says to you, to the nearest hundredth, that obviously means you need a decimal. And you can plug it in. So this way, it's flawless. Hey, same thing, exactly. So there's my 4, 7. It's a little bit high up. There we go. 7, 4, P, 4 comma 7. Determine the primary trig ratios. So we drop down. That was 7. That's 4. We've now got ourselves a nice triangle here. Theta. We've got 4. We've got 7. This we worked out from before to be root 65. Right, that's what we found from the previous question. Sin theta. Cos theta, tan theta. Those are the answers I'm looking for. So, sin theta equals opposite over hypotenuse, right? SOHCAHTOA. So, sin theta is equal to, the opposite is 7, the hypotenuse is root 65. Can I leave it like that? Why? That's right. So how do I get rid of it? Multiply by root 65 over root 65. And so it's going to be 7 square root 65 over 65. Cos. This equals adjacent over hypotenuse. It's cos theta to be precise. The adjacent is 4. Hypotenuse is root 65. So we're going to have 4 root 65 over 65. And lastly, tan is opposite over adjacent, TOA, right, which is going to be 7 over 4. Easy enough? All right, should be nothing really that you haven't seen. You really have done nothing at this point that isn't reviewed. Okay. To the nearest degree. Well, we've got 3 ratios. We can use any one of them. Which one's going to be simplest to type in the calculator? This one right here. And it has another added bonus. And that is, what if I got that wrong? I did the work all right because I'm smart, but I just typed it in my calculator wrong, and 16 plus 49 doesn't have to be 65. That's right. If I use either of these two here, I'm using something that I calculated. So a good strategy is, if possible, deeper in a multi-part question, always use the values you were provided if you can. Don't use a calculated value if you can avoid it. Right? There may be times where you have to use something you calculated. But in this case, you don't. Because if you screw up that root 65, maybe you're going to do this calculation perfectly, you're going to get it wrong anyways. Not because you did the work wrong, but because you used the wrong value, right? So always try to use the values that are given. So we have our P at 4 and 7. We know that's a 7. We know that's a 4. And there's our theta. We're going to go tan theta is equal to 7 over 4. That's what we worked out from the last question. How do I find that theta? I do inverse tan to the negative 1 of 7 over 4. Now it asks for the nearest degree, so that means it's time to haul out the calculator. So, clear it. See, here are my sin, cos, and tan buttons. And directly above them are the inverse function buttons. So I'm going to go second tan because I need to get the inverse of it. And it gives me a bracket. I'm just going to do 7 divided by 4. In your head, if you wanted to, you could have done 1.75, right? Because 7 over 4 is 1 3/4. Doesn't matter. It's the same thing. You know, just hit equals, enter. Ooh. Are we going to accept that? You got that too? You got something different?
16.25.
Who got what I got? Whew, I'm glad I'm not alone. Holy crap. So we got a problem. What do we get? 1 point? Okay, that's good enough. What did somebody else get?
60.255.
Oh, 60.255.
255.
Okay, so the answer to the nearest degree would be 60 or 1. You watched me do it. I'm the teacher, so I'm going to accept my answer. Is there any way it could be 1 degree? No. This is like that 350 divided by 2 pi moment, right? When you get 500, you know you're wrong somehow. We missed a humongously big step. Is there anybody with a not graphing calculator? Still using like an old school one? Yeah? Up on the top, like in the display, do you have like a little a D, an R, and a G in there? Ah, so your D is lit. With our big old monster fancy beasts, we don't have that anymore. There's no little display. Do you remember what I'm talking about? Like that little... Yeah. Our calculator is in the wrong mode. All of those who got 60, you're in the right mode.
Okay.
The default for the TIs is in radians. It's in the R. We need to fix it. And I can't remember how. How do you do it? Just hit mode? Oh, you're a star. There we go. Mode. And now you see all the different options here. Ignore everything else for now. And go here. See radian is highlighted, the third one. We need it to be degree. Now, you remember how I told you to get out of your calculator if it breaks, like if it gives you a dim error? If you're graphing something and it's like, it's refusing to graph it, it's not doing it right. Do you remember what I said to get out of it? Okay, I'm going to show you right now. Watch. So, I changed it. There we go. So if I redo the calculation now, second function, tan of 7 divided by 4. Whew! Excellent. Let's say I'm graphing something, it didn't work, it gives me one of these errors, I'm freaking out. What you can do is second function, and then the plus sign, this mem button. And see there's reset there, number 7. Reset. So I do 1, reset all the RAM. Are you sure? Yes, I am. And it tells me it's been cleared. My memory's been cleared. Now when I type in the graph, it'll graph just fine. It clears whatever funky errors I had. The problem is, if I now go back, second function tan, 7 divided by 4, I'm back in radians. So you have to remember to be able to switch it. Check if you're getting an answer that just seems silly. Just double check. Okay, so clearly that would have been wrong, and the reason is it was in radians. If you use Excel ever to do any of this kind of calculating, your answer will also always be in radians. Well, I don't know why it chose to do that, but it does. Don't worry about radians. You won't see radians until you get to grade 12. If you take pre-cal 12, then you'll become very familiar with radians. Otherwise, we're just never going to worry about it. Just know it's there and be able to change your calculator. Okay, so the answer would be 60 degrees. Put the little degree sign in. And 60 makes an awful lot more sense to us, right? That's a better answer. Go. So, navigating. Compass roads, degrees. It's the same stuff. And so we're going to use a lot of trig for doing navigation problems. Or vice versa, we're going to use a lot of navigation problems to practice our trig. This is how we write. It's called a heading or bearing. They're actually two different things, but they mean much the same. What that means is we're going to go 30 degrees south of west. This one's going to be 40 degrees north of west. We read it as west 40 north. What it means is we are 40 degrees north of west. Okay, it's important that we understand that convention. Because here's the problem. An aircraft made an emergency landing 200 kilometers from an airport. Its heading from the airport was east 50 north. Whoa, how do I draw my arrow? Remember the protocol? The first letter is where you start. The second letter is where you move from. So this is saying 50 degrees north of east. I flashed that by quick. I just decided to put that on just for fun. I'm assuming we remember the order, right? It's always north, east, south, west. Never eat soggy wheat, whatever. Yeah. Never eat soggy wieners. I don't know. I was going to get a tattoo like this, but I'm a chicken. They're painful. The reason I was going to get a tattoo like this is instead of an N, I was going to put a big fancy, like, stylized O. Because my boy's name is Warwick. My daughter's name is Erica. My name is Sean. My wife's name is Olga, so it doesn't really fit, but whatever. I'd leave her
Just
off.
change it, it's okay.
I'd leave her off, put a big, like, arrow or something. And set her away. All right, so here we are. Which way is east? That's east. That's north. We're going 50 degrees north of east. So we're going to assume that that's the airport. We'll make that P for plane. How far away was the plane? 200 kilometers away. But the problem is that the rescue team has to travel east and then north to get to it. I don't know, there's a great big mountain in the way or something. So the question is saying, how far do they have to travel in each direction? So the team's going to have to go there first, and then there to go and rescue the survivors. So in other words, what are we asked to find? We're asked to find the Y and the X. Absolutely right. So now it's just nothing more than a SOHCAHTOA problem. What do we already have as information here? We have the hypotenuse, so that means I have to do things that have hypotenuse. Well, let's do the X first. What is that side called compared to the angle? Adjacent. So which one deals with A and H? So, cos of the angle is the adjacent over the hypotenuse. Cos of 50 degrees, we do have that, is equal to X, that's the easterly direction that I have to travel, over 200. So X is equal to 200 cos 50 degrees. Stick it in a calculator. $200 cos 50, just like that, equals 128.56. And the unit would be kilometers. And I have to do the Y part. Which one am I going to use? We've got the hypotenuse again. Y is the opposite side. And so it's going to be so. Sin of the angle, opposite over the hypotenuse. Sin 50 is equal to Y over 200. Y is equal to 200. Sin 50. Y is equal to $153.21. And so the team would travel 129 kilometers east and 153 kilometers north. because it did say to the nearest clone. Yes.
For the climbing Y, I mean, I know it's not the most like easiest conventional way, but could you not use Pythagoras if you like
You,
to also talk?
you could absolutely. Why would you rather not? Yes, and more importantly in my book, to use Pythagoras, what value would I have to use? The 128.56, right? In which case, if I screwed that up somehow, my other answer will be wrong, even though I did the method right. I'm guaranteed it's going to be wrong, because I used the wrong one. So if possible, always try to go to the ones that there's nothing in this second one here that I made up. It was all from the question. Okay? Cool enough?